All right. Let's see here. Hello. Let's continue a little bit. I just want to do a little bit more here. Moves. Yeah. So last time we did this part. Yeah, we're working on the imports, and we've got the struct types. We've got. I'm not sure if this is gonna be useful or not, but we've got the. Yeah, we're parsing all the imports now, so that's good. We've got the cache for the ASTs, so we can execute them. And yeah, the one thing that we need to do now in order to execute the imports is to move the script executor to the interpreter lib code, because right now it lives in like another module in Zig. So I have to move it because we need to execute the imports like we have to execute every import as soon as it's imported. And yeah, so we need to move it so we can create a new executor. And then when we've done that, when we encounter an import statement that needs to be executed, we need to create a script executor for that import, entirely new executor that has entirely blank scope and everything. But I think we need to pass the env map. That kind of makes sense. And then we will get the result of that execution stored in a scope stack, and that scope stack will need to be cached. Well, I guess we already sort of have a cache for it, like we have we just bind it to our previous scope that we had, like the scope that actually executed the import. We just bind it to that scope. Well, actually that's not true, because there could be other modules, right? There could be other modules that import the same module, and both of them need to be able to get to the cache. So we need we also need to cache the module scope. Yeah, module scope stack. There we go. But then we also, if we have, well, this just means that basically evaluate an import expression to be the scope stack, basically, of that module. Yeah. And then there might be some, when we have like public differentiation, there might be some of that stuff that we have like in the scope stack. Maybe things are private, maybe things are public, and who can access what and stuff like that. But we don't really have that right now. But it could. I think it could be easily like augmented with that stuff. All right, so let's start with this one. Move script executor to the interpreter libcode. So here is the script executor. Now, yeah, we basically just want to move this, to be honest. Yeah, we're just moving this entire file. So, and what are you depending on? Here's interpreters, script context as well. Right, so script context and utils. What do you need this for? Module registry. Is this even used now? No, I don't think so. This, actually, I'll just remove this because this is not gonna get used. Yeah, we don't even get an error when I removed it because yeah, it's not used. Execute import. Have anything to do with modules at this point? No. And this one we remove. This one we remove. Render module error. I think we remove this as well. And this. And this. Let's see. Why is there no errors? Oh. Yeah, I'll just remove this as well. There we go. Evaluate import expression. Right. Yeah, this is the one that we're currently working on. So, all right. So, yeah, I need to move this file and the and the context. Context probably doesn't have any. No, it doesn't have any. What you call it? Utils. No, I don't think we're not gonna need. We don't need this. Why are there so many? Oh, these are the tests, right? Reset interpreter with reset interpreter scope with context. Let's just move it here. Like, why is this even? Oh, it's used over here as well. This is a test. Okay, I'll just remove this. The tests. Execute snippet. I think this is like the super old stuff. Yeah. Execute script command. Yeah, it's not even used. I think I'll just remove this. Boom. And this one. Well, okay. We'll figure it out. Reseed from context. Script context, scopes. I mean, we could just do self instead. No, we don't need to pass this. Runtime value, what the hell? Interpreter. What? Oh, it's just value, okay. Okay. I'm not even sure what's going on here, if we even need this. It's doing something. Reseed interpreter scope with context. Okay, we'll figure it out. I'm just moving stuff here and trying to... Yeah, so now this is the only error. What I'm trying to do is removing all the dependencies on utils here. So this is the last one. Forward handle output, because then we can move this whole thing. Forward handle output. What does this do? Standard out, standard handle. It's just forwarding to writers. Okay. I mean, let's just move this to like I don't know, source utils. I mean, it could probably be part of command runner instead, but whatever. But now we can actually do like runic, something like this instead. Yeah. So instead of utils there, we're gonna do utils equals runic utils. But we're gonna have to change all this though. And script context. So now we can just move script context and script executor because they don't have any dependency left on the command module here. I guess we could, yeah, we'll move it into interpreter. Okay. I see, it was a slightly different color for a file module. Interesting. Alright, process snapshot. So we don't have access to Runic anymore, so we have to do like import command. Like where would this be? Front end? Command runner? No. Runtime? Oh, maybe this should be runtime. I don't know. Anyway. Process snapshot. Okay. Then we have script executor. Yeah. Here we have a whole bunch of stuff. I mean, I guess we could import root. No? Maybe not. Why not? Oh, it thinks it's something else. Okay. So you can't actually import Runic because it's not mapped to... Wait. Okay, I think this is like an LSP cache thing. It should have been an error there, yeah. See? Or what? Wait, how does this work? Wait, I thought that Runic wasn't available inside itself. Yeah. Okay. That's weird. Okay, let's just go with it, I guess. Yeah. Maybe, okay. It tries to do this. Maybe this is why it doesn't show the error or something. So let's search for like script executor. Yeah, now this should be like Runic interpreter. Check build.zig. Yeah, it's I don't know if you can add it there, but like to itself. But that would be cool though, because that would be a neat way of importing stuff. But it might also be some kind of caching issue. I'm not sure. Because this has like complained before. Like this way of doing things has been not working before. But maybe if we do this, maybe it will like clear the cache or something. Runtime. So runtime is like the library. So Let's see. Can we just do this? Like we can add it to itself. Like that's weird. Maybe it works. I don't know. You know what? Let's remove it for now. I'll just remove the cache for now. And then we'll see what happens. No? Okay. Well, let's fix these errors for now. Same thing here. Runic, interpreter. Keep to the convention. Okay. There we go. Now we get this error here. Alright. And so let's try doing this then. Does it work now? Maybe? I don't know. I've never done that. I've never added like an import to itself. Like it feels like you could easily get to some circle dependency issues, but yeah. Let's see how far we get. It looks circular, yeah, but I mean, to some extent, it could, you know, run until it, you know, gets to a loop and abort. But so it is. I mean, technically, it is a circular dependency if it depends on itself. But it might work anyway if they. It depends on how they implemented it. If they have like a special case for importing itself and then just trying to, because it would be really nice, because this is a way to have absolute paths when doing imports, so you don't have to change. Like let's say I change the path of the interpreter, I move the interpreter to something else, but we don't need to change these imports here. But you would have had to do that if you use just add import everywhere. So I think this is a really nice way of importing things. But let's see if it works, because it might be some, you know, it might not crop up until runtime. Hopefully not. Hopefully there's no such issues, but okay, we've moved the executor. Now I'm gonna check here. Here we create. So here's the run script function. This is the entry point for actually running a script. And we have the modules and everything. Let's remove that. I'm just gonna remove all this crap. Okay, no more modules. Great. Parse imports. Yeah, this one we did last time, so we're basically going through every import statement and parsing everything, so we have everything in a nice AST cache tree. Sort of, or it's, well, it's not really a tree, it's, yeah, we're storing things in the document store, that's right. And we could also store, like the document store, we could store the mod, like the result, the scope stack as well. Yeah. Okay. So what are we doing? We're initializing the executor. Yeah, we're passing the document store. So this is what we're gonna use instead of the module registry. And I guess we'll do the same thing here. We'll take this. I'm not sure about the initializing though. No, let's keep the whole executor alive. Yeah. We'll do like this. The document store is gonna have script executor. No. Interpreter. There we go. Except it's gonna be like nullable, so that when, let's just set these to null. So when we encounter this and this is null, then it's not cached. So we have to execute the script, the import, and then we can supply the thing. And this would include the scope stack, so yeah, and everything else that's probably needed, like environment map and stuff. It's gonna be interesting though. Like if you execute, well, I guess we'll get to that later. With environment maps, because that's kind of a weird, like, global thing. But let's see. Yeah, so, but if it already exists, then we can just use it directly. All right. So we're loading it. Now, we wouldn't actually, would we need to do, yeah, I think this is used by, no, yeah, that's used, so basically request document, this would have to exist when we are in the script runner, because we should already have loaded all the necessary documents at that point. Because we don't have dynamic imports. So we would know every document. So we've loaded all the documents in. So it should be available. Okay, well, anyway. Okay, so let's see. Right. So here's kind of when we populate the executor. What is this? I don't understand this reseed. Like, why would we need this? This is like an empty. This is like an empty context. And we're not modifying it, so what's the purpose here? We're going through all the bindings here, but then we don't have any bindings. So that doesn't make sense to me. Why would we even need to do this? Unless the context is modified along the way. No. So can we just remove this? Well, it's pushing a frame. Well, okay, whatever. It's doing something. Probably. Okay. But we don't actually want to reseed. We want to reseed from an empty context. Yeah. Let's. Yeah, we want to do all of this. And then we go to evaluator. And here we go. So either we have a cached result, we can use that. Wait. Yeah, we need to change this. Because this is going to get stored in the document store instead. Yeah, we have this in the document store. We have parser. We should have all this in the document store instead. That makes more sense, I think. So let's just remove this. And this has like everything we need anyway. So the other thing is this one, I guess. Just caching that. I don't think we even need that, to be honest. Let's just forget about that one. Yeah, and then this, I just remove this. Yeah, get cached. Let's call this like document instead. And this will return a document. Let's actually do a pointer. So we can potentially modify it if we want. Yeah, but it is by module name. So this is like a relative path to the file, I guess, probably. And then we resolve that, and we will return document store request document path. Which will return a document pointer. However, like what happens if this was null? Then we need to execute it. No. So actually, this is not a nullable. We get the document, however, it might not have been parsed, actually. So we need to see, well, we need the parse result, though. So we will get the document here. Unless there's an error, of course. But we'll get the document. If this is null, then there should be then we have an issue, because we don't support this. So this should be like I don't know. This shouldn't really happen, like document not parsed or something. I don't know. Okay. And here is like, if we have this, I guess we could check this first. If we have this, then we already have the result. So this would be the script executor. And what would this resolve into? Some kind of value. It should be the whole scope. Well, it's not const, because we could modify it potentially. Where is this interpreter? No, where is the interpreter scope? Hello, Metallics. How's it going? Switch my center, all possibilities. Well, we don't clone it because it's a pointer. Why would we? Yeah, I guess we'll run into issues maybe if that's materialize string. Hey, could you help me get a job? So Google, get me a job. No, what kind of job are you looking for? I can't give you a job. I mean, I'm not running a business here. The interpreter is going good, I think. Currently working on the imports. Hello, hello. Hello, Arsh and Altrix. How's it going? Welcome. Use of underclaim. Oh yeah. So we need to import that. There we go. Yeah. We need some stuff here. Now the runner, what kind of context do we have with that? What is this? Okay, you should just be able to we should be able to reuse the same thing, I think. I'm pretty sure. Like, what's the purpose of this? It's like the tracer, I guess. Is this a NeoVim distro? It's just my NeoVim setup, and I'm making a script language. Yeah. Follow the advice there. You just have to apply to a whole bunch of places and hope that you get... And then go to as many interviews as you can, and you know, until you get hired. And in the meantime, you could, you know, work on projects that you can actually show, like your portfolio and your skills and everything. Looking at Zig for the first time kind of reminds me of GoLang. Okay. I haven't done GoLang too much, so, but I mean, when I first wanted to get a job, it took a while to get one, to be fair. And I think, but also, like, I don't know about the landscape right now where you are, but here it's kind of tough for juniors, unfortunately. Oh, yeah, there's the runner. Wait. No. Yes. No. Wait. Hang on. Wait, how do we get... We need the current executor as well. Well, we should be able to get it from the document store, maybe? Yeah, so I was trying to create tracer parsing for my programming language. I've highlighted, but it's insanely hard, so I wrote Vim syntax highlighting. Yeah, I think the tracer, for me, the hardest part was to get like all the the process in place. Like the actually defining the grammar is pretty. That reminds me a lot about how I used to, like, if I want to build my own parser library, that is how I would build it. Like how they do it, like you have like sequences and choice and all that stuff. It's more powerful than the Vim syntax highlighting, I would say. Or yeah, I think it has more potential because it's more, you know, you're programming it Vim syntax is more like you're declaring kind of what you is. Yeah, it feels some of the things. It's very easy for some things, but then if you want a more complicated syntax, it's becomes really hard, I think. Offended by likeness to Golang. Okay. I don't know. I've not heard that. Do you have a Discord? Yeah. We had I mean, the thing is, like, I had a person who when I went to school, who always wanted to take the shortest route to whatever. But that's not how it works. Like, you have to practice, you have to get good, and then you will get like confident in your skills and everything. And but also it's important to be able to show what you've done as well. Let's see. Yeah. Can you make it a functional language? The purpose of this language is to be a scripting language. I can show you a little bit here. So it's basically gonna be, like Bash, except it's gonna have like different syntax, and possibly, type checking. So and here you can import other. That's what I'm working on right now, like making import work. So you can import other files. So let's say we import this file here, and then you would be able to access the scope of this file as well. So this is kind of the idea. It's like my personal Bash replacement language, because I can never learn Bash. I refuse to learn Bash because of the syntax. It's a really nice language. Like, Bash makes it's a really nice, way to quickly get some workflow in that you want. But I can never learn the syntax. I have to look up stuff all the time when it comes to that. So I'm just making my own language. I mean, an easier way would be to make. I've been thinking about this as well. Like, an easier way out, instead of like making a full-fledged language, is to make some kind of preprocessor thing. But you wouldn't get much like debugging help from that. That would be horrible to debug and stuff. But you could do like a preprocessor thing that would like compile into Bash, and then you run it with Bash basically. But yeah, I want to do it like this because I am interested in programming languages and making them, and yeah, I would say this is the most advanced programming language that I've done so far. Like, all others have been like very very simple things, just to learn the basic things like how to make a parser, how to make a tokenizer, lexer, and the compiler. But this is not going to be compiled. This is going to be just interpreted. So, and then I have an LSP. So I have a basic like LSP implementation, and I'm gonna extend with a type checker hopefully as well, because I've never done a type checker, so that's gonna be interesting as well. I have created a compiler before, yes, but for a very simple language though. But it did work, and it worked. It produced ELF executables. which is, you know, Linux programs that could be run on Linux, basically. And I did all the like assembly and everything manually. Yeah, but you could use, if you want to do that, you could use like the linkers from you know, GNU or whatever. Yeah, but anyway, but I made my own stuff entirely there. But now I'm making a scripting language, so this is going to be entirely just run with the program directly. Okay, so so right now we're working on the import, and we're trying to evaluate an import expression. Now how it's going to work is that either we have already imported it from before, so we should have like the result should be cached, and we shouldn't execute the import file, and that's what we have here. So if we have one already, we will just return the result there. If we don't have that, so we need to actually run the imported file as a script, and then the resulting scope will be the value that this will be evaluated into, so that you could access, you know, functions and variables and whatever on like declarations on it. And that's what we're doing here. So right now I'm making a new script executor here, and but the problem is that we don't have the old executor. We need the old executor, like the current executor for the current script right now. So we do have this import expression, which includes importer, which is kind of like a, yeah, that's the path to the thing we have right now. So that should be possible. We should be able to get the script executor from this actually. So if we should get like the current executor or current document. Oh, okay, wait. No, this should just be like try self document store, and then request document, and then the path is going to be the importer. Yeah, so then we should, now we have the current document, and the current executor is going to be current document.script executor. And that should be available. I use NASM for my compilers. My compiler is able to compile the Windows. Yeah. That's cool. I mostly did it for, you know, it's not a feasible thing to do if you want to, you know, be productive. But I just did it for the learning experience. It was quite interesting. There's a lot of things you don't think about when doing the stuff, like manually mapping all the addresses and everything. I mean, yeah. And then there's like, you could do all sorts of weird stuff on that level as well. But yeah, I'm probably not gonna deep dive into that anymore. Unless I want to make another compiler, but then I would probably look into doing something like that, like using an existing assembler or something, and just compiling to that assembly language. All right, use of undeclared identifier runner. Yeah, so now this would be like current executor, and we assume that it exists. We have the bridge. We assume that it exists, and we have the runner. So that we should just reuse the same runner. That's fine. And we have the environment map. So this should be the same environment map as well. Now the issue here though, should we treat environment map as a global store, because then we just pass around the same environment map. I mean, I know in Bash there's such things as subshells, and those have like, you know, you start with a, or do you start with a clean slate, or do you inherit? So you can see here that, let's say we do this. So we would expect this to be like 1, 2, 1, space, space, space. Right, so whatever environment we have here is going to be inherited by the subshell here. But whatever environment variable is set in the subshell will be, you know, not exposed to the outside. But this is kind of different, maybe. So basically, we import lib here. The question is, should the environment variable set in this part be in a subshell or not? Maybe you could, like, you assume that it would use the same environment if we just execute it like this. But if you have like a subshell, let's say you have, I don't really know how the syntax is gonna look like, but let's say you have a subshell like this or something, and then import it, then the environment is gonna be, yeah, we could have the same idea. So I think for now we are just gonna treat it like a global store, I think. So this is just gonna be like the env map. Yeah, we're gonna reuse the env map there. And then we have document store. We can just, yeah, we have to reuse that as well, of course. Okay. But we do not initialize. We do not reseed from context. However, this does things. It pushes a frame, which we don't do here, I don't think. Oh. No. Yeah, I think that's the only thing that's happening here. We're pushing a frame. So I'll remove, well, I don't remove the entire function. What we do is we just say scopes push frame, I guess. And what this is doing is it's just appending a frame here so that we start with a frame. All right. I don't know, Olive the boss. How's it going? Welcome. Standard use of undeclared failed to initialize script. Okay. I think we'll just return this. I think we'll just do a try here, whatever. Like, what can happen here? Just, you know, out of memory. Yeah, it's just an out of memory thing, so. Okay. And then we do the execute. We need the script AST. That one is on documents.ast. Actually, you could do this. You could do like script AST equals document AST, or else return error. Document not parsed. So now we can use this instead. We don't have to do the unwrap. Excuse me. Okay. Script path. That is gonna be. We should store the path in document. We don't do it. Yeah, we should store the path here. And that could just be a link to back to the store key. Because that's the absolute path. Path is gonna be path. It's NeoVim, yes. Alright. So now this should be like current. No, this should be document path. Okay, standard out, standard error. That's right, we need these things. That's right. That should be on the current executor as well, maybe. Or is it on like the bridge? Runner? No. It's not stored anywhere, so it's just on the execute options. Okay, maybe we'll save that. The options. We'll save the options in because it's never gonna really change. We're not calling this multiple times, really. Well, I guess we are, but actually maybe we could just call it again. Maybe we don't need multiple script executions. But the problem is this scope stack. We need a new scope stack. That's the whole problem, though. Also, is this even used? No. What the hell is this? I mean, we could just make a new standard error. It's not really a big deal. We could just make a new one. Well, although this could be an issue though. What if it's like redirected? Whatever. Let's fix it when we get there. Context. Yeah, I think this one what does this have? Bindings. I don't even know if this is even used, to be honest. But I'll just make a new one, which is script context. And then, yeah, fine. Wait. But this doesn't work. If we're gonna keep this around, we need to create one. Yeah. Create context. And I guess the same is for these, but this is just gonna execute once. This is just used once here, so that's fine. The dir. Wait, what? Why do you need? What's this used for? It's just used in a bunch of tests. I'll just remove this as well. All right. There we go. Hopefully there's not a whole bunch of errors now because of that. All right. Executor. There we go. All right. Now this huge errors is because of the error type is missing something. So we're missing, I don't know what we're missing. Maybe something from here. Real path alloc error. No. Something else. That is just out of memory. Oh, this one, the file, open file error. Yeah. What? Even more? What can it be now? I wish this could be like auto-populated. But that might be a hard problem though. What else do we have? Read, short error, standard IO. There we go. You want a writer and not a reader. Oh yeah. Oh my god. Okay. That's right. That is right. And now we can do like empty process here instead. So that's good. Okay. You know what? I'll just take... Okay. Let's just do this. Yeah. What? It depends on itself. Okay. What do we have? This one. Let's just. That should already be like. Okay. Let's try adding that. Writer error. Is that enough? No. That's the only thing here, I think. And then this one. That's the only one. Or this. Flush. That's a writer error. So this is just a writer error. This one is... this part is like... it's like if you have defined all the error explicitly, then this is way easier than what I'm doing here. Now I didn't do that, so I have to, or at least, yeah, the AI, whatever. I have to go in and look at all the possible errors that could be. This doesn't even have an error though. This is not even. Wait, it does have an error. It has this error. Duplicate binding. Oh, and it's not even specified. Okay, it's not even. Okay, let's just do script executor error. What? Oh, if the error is that, then we return. Oh, what the hell? Okay. Oh, you're a binding error. Okay, I see. Binding error. script context. So you are actually a binding error. Okay. So this should also be a binding error. Okay, there we go. Now, there's some cleanup there to do, but yeah, this, okay, so we just get an exit code, I guess, here now. And sure, that's great. We should have all the other context in here though. The document should have... Actually, yeah, when we get here, like if this didn't like succeed, like how... Okay, so if we didn't have any statements, then it's null. I guess if we didn't have any statements, then... I mean, we should just force that to be 0, then exit code, I'm gonna say. Anyway. Okay, so now we've executed that. Now, there's a lot of things to think about here, so... we've executed it. We need to store the result. Also, before we execute, we have the script executor here. We should then say current document executor is going to be equal to that. Actually, we said it. This should be like the source of truth here, and then we can say, well, we can say executors the pointer to that. All right. Yeah. We know it exists, so could do this. Okay. So because then the document has this stored, so the next time we do an import, we get in here again, and then when we get the current documents, the current document here and its script executor, that's going to refer to the same executor that we set here, so that the next time we can actually import using that one. And so here we create a new one, we set it, well, we create a reference here, we push the frame, create these things, yeah, we create the context and we execute the code. Okay, now we get the code here. We don't return it. We just get the exit code is going to be equal to this. Whoops. And if we don't get it, I'm just going to say it's 0. That makes sense. And then In fact, it doesn't really make sense to get 0 here. Like, why would, or null? Why would we get null if we don't have any statements? It should just be 0, right? It doesn't make sense. Okay. Yeah. Right. Now. Yeah, so now we should have everything we need to store in the document. We need to store the... Well, we have the scopes in here, so it's already evaluated. We don't really need to do anything else here. I guess maybe the exit code we need to store as well, perhaps. I mean, it could be good to have. So let's just store that. And then we need a value. So the value is going to be this here. All right. Now we need to add exit code. I don't know, I'm mixing conventions here, but I don't care. That's probably gonna piss so much people off when they see it. Let's see. So that should be good now. All right, cool. All right, no more errors in this file. Missing struct field exit code. You should be set to null. Okay. And yeah, we just return. Yeah, you see even here we default to 0, so it doesn't really make sense to do this here. There we go. And same thing here. Well, I guess this, we get the code. And then we'll do this if down here, I guess. All right. Okay, no more errors. Does that mean it works? Maybe. Well, I guess we'll try it. Well, it might be more errors. No? Okay. So we'll go in here. I'm gonna do it very simply here. We just import lib, which is going to echo this out. So if we run, we get an error. General protection exception. Resolve path. Parse script path. And then we request the document. Right. No, not the parser. Wait, why do we do like parser here? Parse script. Get source, request document. Oh, I see. We're not actually running the. Okay, this is just a parsing part that fails. I see. So, is this parse? Parser 206 run script 54. This path is passed from here. That should exist. Maybe it's self? Is it self? And we're doing it here. What's the language for? It's like a replacement to bash script. General protection fault. No address available. General protection exception. Hang on, I'll just check. Any reason you're making it? How is it different from bash? Well, the reason is, well, there's a couple of reasons. So one reason is just I want to make a language. That's like the most, I guess, the strongest reason. But another reason is that every time I've recently started to use bash more, like creating like bash scripts, and you know, I constantly have to look stuff up, like how do I even write an if statement, like where do I put the semicolon, where's the then, you know, it's like the syntax is always tripping me up every time, and it takes so much time and energy to just do it. So you just consider, okay, well, maybe I'll just write it in, I don't know, some more familiar like programming language and just make a program for it instead, you know. And it defeats the whole purpose of bash, which is like you want just a quick and dirty little workflow thing that you want to make, but the syntax of bash is like really holding me back on this. So I just wanted to make a language that could solve that issue for me. So I'm making basically a language that has zig syntax and bash combined, you could say. Yeah. No address available. Is that because I'm accessing Like here, document store is like, doesn't matter. We're only accessing like allocator, which is copyable, so that's fine. I usually don't get general protection exception. I usually get like seg faults when it comes to these things, so I'm not sure what the difference is, to be honest. Tries to access memory that's not allowed to, yeah. Okay, well, it's the same kind of error, basically. I mean, it's like accessing memory that, you know, that you don't have. But which one? Is it document store? No, where is it? 54. Do you create the parser? You create the parser, okay. And document store is stored, it's stored here. Which should be good. I mean, if we want to make this super good, we could, or you know, resilient, we could make it, we could do like stored arena, allocator, create document store. So that would allocate enough memory to keep a document store. And then document store, we populate it with this thing here. So now this is a pointer instead. I don't think that's the issue though, because yeah, because it should live through this entire thing anyway. We're using pointers to it anyway, so, but I don't know. We'll see. Whoops. No, still the same issue. So the only other thing is like the path here. No. Wait. This comes from run script 55. The path comes from script, which comes from here. That should exist. There has to be something else. Where's the path? God damn it. Wait, I can do this. Mode, script. Okay, there we go. Mode. Mode, REPL, mode, script, path, script, path. Alright, it's trying to find it here. Duplicate slice. Okay. So it's either null or duplicate slice, which uses this allocator, which should just be the GPA, I think. Yeah. Okay. Yeah. It doesn't make sense that this would be the issue, because we're using this all the time. Maybe it's something else. But this goes straight to this. Like, what if we change this to just echo something? It still fails. Okay, what about this? What about this? Where do we have like the thing? Document store, here we go. Get source, yeah. This parser. It's used here, except we don't really use it. Yeah, we create it here. We create it for the document. So it should reside in the document store. Then we're using this parser to parse the script. And the parser itself we initialize here. And the context is the document store, which is self there. Like, this has worked before, I'm pretty sure, or maybe it hasn't. Maybe this is, we haven't tested this out yet. But this should be the pointer to the document store. This should be just be self. This is called from request document. which is called from here, which should be just the pointer that we just created. Like, I'm having tunnel vision because I'm trying to see what these pointers could possibly be. Have an error here. Yeah, here we're reading in the file. We probably don't need this much. Let's do it like this. I don't think that's the issue, but no. Yeah, this is just, we're just reading the file all together at once here, and then we close this file off, so that should be just done there. But that's not even where things are going wrong, but sometimes it's like adjacent places. Now, where is it? Okay, let's look here again. Front-end parser, get source, document store 82. It's basically the first thing that happens here is causing an issue. We're going in here, and then there's a general protection fault exception. No address available. Okay, let's do this. Let's check. Let's do. Let's change this to be. I mean, real path. That should, like, it fails if there's no path at that point, but that shouldn't be like a general protection exception. I'll just change this into like a path resolve. What the hell? What? How do we get a different error now? Okay. That is very strange to me. Let's also... I'll just do this, just in case. Let's do this, and then go back. Actually... Yeah. Now, all of a sudden, this other issue is gone, maybe? I don't know. Yeah, I'm pretty sure allocator is copyable. So, but okay, whatever. We'll do this. Wait a minute. Maybe it's because the arena is... No. I don't know. Whatever. Let's just do that. Let's see. Okay. So basically, we're getting an assert. Open file absolute is absolute. Wait, now we're getting an error somewhere else. It's complaining that this is not absolute now. Which is here, like, if this is absolute, we return it. If it's not absolute, we make it absolute with this one. So this is real path. And it says, returns the canonicalized absolute path name of path name relative to this steer. Yeah. So the input is relative. The output is absolute. So we should get an absolute path out of this function. Right? But it fails in checking the absolute path here. And now we get a general protection exception. Okay. What if we go back to now? We go to path and resolve. I'm not sure if this actually, if this uses real path or what this is doing. No, probably not. Yeah, I don't think that would solve the issue. We still get this assert here. Now we're getting assert here. Because resolve on Windows. Okay. Man, this is the worst documentation part. Like some parts of the documentation. I'm not saying that zig documentation is the worst documentation ever. I'm saying that this specific documentation is very bad. But you can go in here and check. So at least we got that. Series of CD statements executed once it resolves, but will not convert relative to absolute path. Use real path instead. Oh, I see. But what? Ah! I thought it would actually do that, actually. I thought this would convert it to absolute. Alright. And apparently this gives a real, like this gives a general exception, general protection exception, path name. That's not too much. We should be able to keep that on the stack, I think. Wait. Yeah. But maybe, okay, maybe we do have like too much on the stack. I don't know. I wish there was a version of this that didn't use the stack or something. I don't know. Or maybe I do have some other issues that I need to deal with. Maybe... Let's try... We'll return that. Right, and then we'll go to main, or we'll go to run script. So the store is stored on, like in the heap now. The runner doesn't really have much. Wait, where? We put the document store here. Where is it put? Just in the evaluator, okay. But this isn't even where the issue is. The issue is like up here. Man, I don't know, man. I think in these situations like this, there's like tools like Valgrind, maybe you can use. Not sure how you pronounce it, but I've never done that actually. Yeah, it just fails immediately here. Well, self.path equals the path. And this is script path. And that's there, yeah. And this is just a pointer, yeah. Oh, man. Yeah, I'm stumped. Let's see. Okay, I guess we'll see if we can do that. It couldn't be this. Let's try this though. We'll remove this. Then we should get some errors. Frontend AST. What is this? Runtime? Parser. Which one's the front-end parser? It's not even used. Alright. Well. I mean, I'll just remove all this. I'll just remove these. There we go. Is that the issue? That would be insane. No, it's not. Okay, cool. All right. Cool. But we still have issues. So let's do like CLI. All right. Whatever. Okay. Good. Now we have it. So we have, I don't know, I found this oops. I've never used this before, so I'm not sure if this is even the right tool for this, but I guess we'll see what pops out. And, you know, there might be other flags you wanna use, maybe, I have no idea. Why is it taking so long? Ah, wait. It's not stacked, malloc, or freed. This is an undefined address. Serious error. But it's just a warning though. Yeah. Alright, yeah, it's badly formed. Okay, is this part of the same thing here? Invalid read size of 1. Let's just try this. The libc made it take a longer resolving path. Why does it say 3 times? Okay, that's not good. Let's remove this. What? Okay, we might be like stuck in a loop maybe? I don't know, this doesn't make sense. Okay. Right, the first request is here, so that makes sense. Why are we requesting again? Maybe because of get source? Yeah, okay, I guess that makes sense though. Resolve path. Because we're not initializing the input either, which could have happened. Yeah, so the third time it doesn't work. This resolves fine. Self-allocator. Okay, let's go to parser. Parse script. Actually, let's go document store. And I will do get source. There we go. So we'll log that. I don't think this is part of it. Put cache AST. Get cached AST. We could also put the path pointer as well. Okay, here we can see get cached AST. This looks good. This looks bad. So this, okay, I recently learned this a couple of, like a week ago or something, that in Zig, if you make an undefined pointer, for example, in like the Zig debugging version, like when you compile to like in debug mode, it will put all the undefined values to this value here so that you can easily see, okay, hey, we forgot to set an undefined value. Well, easily, I say easily, but we had to do some logging to actually see the value. But yeah, why are you making a new language? Because I want to make a scripting language that I can use instead of Bash. And because it's fun. And educational. Let's see. Okay, so, but at which point? So this is get source, right? But at which, so we parse script, we get the cached AST. That we do here. So it's like in the same function, we get the source. For some reason, this is set to undefined. Calling. Yeah, because parse script, this is like, it's saying parse script when we get into the function. So we're never getting into the function again. This is the same call. First it's this, then all of a sudden it's this. So it's after this has been set. How can the pointer change? Toggle term? It's the name of the plugin. I don't know. It's just, you know, you press
a button to toggle the terminal, so it's let's see. What is happening? I'm trying to figure out why does this pointer changes, because even if this was put in here, they couldn't change the pointer itself. They would just get a copy of the pointer value, like, or the like the pointer. Yeah, I'm doing great. I'm trying to figure this thing out. This is weird. How are you doing? Are you a developer? Doru? Let's see. Get parse. They get cached. I mean, okay. The only thing that I can think of is that there's something weird going on with the allocators, perhaps. There might be some. Yeah, it might be that some other allocator is like overwriting the same area as some other allocator. That's the only thing that I can think of right now. So if we go to run script, yeah. So the way I set it up here is I have an arena with this allocator. This should be just the normal like GPA allocator we get from outside here. So we get this arena, and then we create the document store in the arena. I mean, that should be fine, right? Now when you do this, like you call this allocator here, you should be able to call this how many times you want to get the actual allocator. That should be fine. Two allocators do that. They touch the same buffer. Yeah, it could be. It could be because of the allocation setup here. Because I recently changed it here, and yeah. We have the document store arena. Maybe we should just have an arena for the entire thing. We should just have like arena. Maybe. Because this is gonna live throughout the program anyway. And then I'm trying to see. Parse imports with allocator. See, this is where it gets wrong, I think. Maybe. No, maybe not. actually, because we don't have import statements. No, this should be fine. We're never getting here anyway. So we have this arena. The document store is created with the arena. And it also uses the arena allocator for itself, which is how it's supposed to work. Like, we're supposed to have an arena allocator put in here. And use that to store stuff. So that's fine. Yes, I'm streaming at Twitch, yeah. Now this one runs fine, but as soon as we do this, shit hits the fan. Wait, you also have an arena. That's right. Okay, it could be this, like the parser also has an arena, and there, like, for some reason, two arenas don't mix. If you create an arena from another arena, that can be bad. I'm not sure if that's mentioned here. Okay, we'll do this instead. I'll put an arena here. And I'll put a deinitialize. Okay. All right. Good. So glad I'm not the one who has to code this language. Yeah, I mean, I enjoy it. I think this is fun. It's a little bit the feeling that you can like you can create it. I mean, it's not, you know, it's not sunshine and rainbows all the time, but when you make something that actually works, that can be like a incredible feeling. So, like, but it has to work though. That's the thing. Okay, I think we can remove these things now. Well, okay, actually, let's keep them around until we're done. Okay, I messed up what I was doing here. Arena. So maybe, yeah, we don't want this actually. I will get rid of you. And we'll just... Actually, I will do this. Now we'll just put the allocator instead. All right. Wow. That's cool, Metallics. And like the issue is like the more things you can do, like the more things you build and you felt like, wow, this works, then you have to build something more complicated the next time in order to get the same feeling. Yeah. I'm mixing the conventions just to piss people off. Oh, I don't actually really care. It's like the only thing I care about is capital letter in the beginning. I don't like this. I usually don't do this, but I do it now because the AI generated a bunch of these. So, and I have a compulsion to, like, you know, follow the convention. However, since I also wrote code, it's now mixed. So the convention is actually that it's mixed. So that is the convention. So there is a convention here, and it's like, it's up to you. No, but I understand the convention is that apparently function names should be Pascal or camel case, and variable names should be, you know, snake case. But I mean, I think the only reason why that is the case, well, this might be a I'm just joking, but probably it's because of shadowing. You can't have shadow. You can't shadow anything in Zig. So, but you know, I don't care. I don't care that the official sort of convention is whatever. I will always use this, even if I'm, you know, programming in C or whatever. I'm gonna use this convention here. Like, that is to say, if I'm working in my own project, if I'm working in someone else's project, or, you know, some kind of in-house project or something, of course you have to keep to the convention there. But this is my project, so I can do whatever I want. Yeah, okay, so if you see, we have document store here, right? This is in the outer scope, or this scope. I make a new scope, so here now we have a new scope. And I want to say this is a document store in it allocated. This will be a shadow. That is an error. Snake case for functions, camel case for variables, structs. That is Pascal case. But it's not snake case for function. It's the other way around. It's snake case for variables, camel case for functions. This is camel case here. Functions or camel case, variables or snake case. Yeah, that is one of the things that I don't agree with all the time in Zig. Like, shadows are banned throughout, but I don't think this. Why would this be an issue? I mean, I think the reason is, or the argument is, that it's like harder for the programmer to know which one you're talking about. But really, like if you have a small scope like this, it would be very obvious. Like I'm so used to that you can do it. Like it has tripped me up. I don't know, I could probably count on my fingers how many times that issue has tripped me up. There's more times when this has become an issue, like you can't shadow, than the shadowing itself being a problem. I don't know, maybe I'm missing something, but yeah. I feel it makes sense in some cases, but other cases I feel like it doesn't make sense. But yeah, that's just how it is, so you have to live with it. It's fine. Okay, so we got rid of the arena. Now we're doing this. This has its own arena, fine. The parser should be initialized not with the arena, but with the allocator. Yes. But this should be the arena. And what else do we have? This should also be arena. And this should be arena. Alright, parser is the only one that has that. Good. Okay. And then we defer document stored, initialize. There we go. Okay, so now everything in here is like stored within arena except for the parser, which has its own arena. Great. Let's see if that works now. No. Man, still the same issue. What, Milano? No, I'm Swedish. I use snake case for functions. However, we do have a pizzeria here that's called Milano, which is interesting. But I use a snake case for functions. For example, I'm writing a library called HTML. It will be better to have functions that look like HTML parsers, not that HTML parsers. Oh, you're saying that you have that. Okay, I see. Well, I don't know. I'm very used to only using, like, I'm using what the hell is it called? Camel case for variables and functions, and then you know, types is I want Pascal case. But I mean, I can see the utility of having this as lowercase, because then you would immediately know, is it a function, is it a variable? But it's I mean, that distinction is not that important, because the LSP will tell you. It's only if you don't have like utility tools like LSPs that would actually be helpful, as I you know, unless someone can give me other arguments for it. There's probably a lot of arguments for it. I don't know. It's just what I'm used to. Hello, Jemin Zuzi. How's it going? Yeah. Well, the LSP is very helpful. It has been... it's not perfect, but it does help a lot. Yeah, LSPs are amazing. And I understand people who don't want to use LSPs also, like, because you can always have the docs ready and look up stuff, you know, but then you have to keep more of the stuff in your head. And if it's like an entirely new library, I mean, yeah, you would have to read the docs a little bit, but you do get a lot of help from the LSP. In Zig, where you don't have to do prefix for library functions, it doesn't matter that much, I guess, but in C it makes sense. Yeah, in Zig everything is like namespaced. And you decide what things are called, basically. You don't get a whole bunch of trash in your global scope when you import a file that you can't see. Everything is like named and visible. This is a trash account. Won't look me over it. Okay, I see. I'm still with you. I'm not understanding moving pointers. Okay, so yeah, the only thing that changes, that can change the pointers in this case, is the allocators. So that's why I'm trying to figure out what is happening with the allocators, because these functions don't change the pointers themselves. Like I don't explicitly say that. Where is this? Like that the pointer changes after this line of code, then the pointer has been changed. So there's something in here that makes the pointer change, but the pointer we're talking about is this pointer here, and I'm not giving this function writable access to this pointer. I'm just giving it the pointer, you know, the address. I'm not giving it the pointer of the pointer. I'm just giving it the pointer. So it cannot by itself change this pointer. So it has to be the allocator that changes the pointer. And or okay, I was maybe lying, but we're not giving it the pointer. But it might also be that, but because this parser is part of the document itself. Hang on. Yeah, the parser is stored here, which means that we could technically, if we have the document, we could overwrite this, so that would also overwrite the pointer. Yeah. So if we, for example, go get here, we are making a new parser that, but we are using the same thing here though. I will, okay, let's do this. Let's do like log debug, so load document. Int from pointer. Yeah, so this opens this, we shouldn't get here. We should only do it like the first request. Right. So even before we're calling parse script, we do load document. This gets the cached AST, so we just return the thing. So after that, the pointer is messed up. This is set to load document. Yeah, if we didn't find the existing, we load it, right? Otherwise, we return the document. This is a constant. Should we store them as pointers, maybe? No. That doesn't... Well, actually, the parser will get copied. Maybe the arena can't be copied. Or something like that. Okay, let's do this very, very carefully. We'll just store pointers of documents instead. And then you will return a pointer. And now we have to dereference here. You will return a pointer instead. And we'll get the document. It's gonna be like, I guess, arena, create document, and then you are that, and then we return you. And we have to try. Okay, it should be okay to copy the alloc interface to an arena, not the arena itself, right? Yeah, I think there was some weird stuff going on with the arenas there. Okay, but now we also no, we don't need to do anything here because we just clear the arena. Okay, cool. Okay. Okay. Well, that solved one issue. That solved this issue. Nice. Okay. So, yeah. Cool. And then it parsing all this crap here. But then we get something. Oh, we get a leak. Oh, that doesn't... I don't care about that. See, and then we execute the thing here. Awesome. Great. Okay. Let's disable logging. And I'll get rid of all these logs here. Yay! Okay. So it works, but we have a leak. Talking to that seemed to have helped a lot. Yeah. Sometimes you just have to also like bang your head again. Like you have to just dive into everything and explore every option, but that is like the most. I usually try to have a higher view first, and then or a tunnel vision first, and then where I like try to find it based on previous experiences, and then go through this tedious thing. Hello, do you have questions? Do you have lessons about AP exam computer science A? AP exam computer science A. No, is the short answer there. Also, what is AP? Applied programming? I don't know. Man doesn't use telescope, but quick fix. I use telescope first, and then I turn it into a quick fix so I can use the results. Like, okay, so if I say like, I don't know, print, I can do this, and then I can like go to everything here. That's how I... I mean, okay. Let's say I want to change all the consts to vars. Or find everything, and I go through like this. So I can keep the context around and don't lose it. Yes, you can. So you do like telescope and then Control Q. You will get all the results into quick fix. That's nice. Okay, thank you. Are you an AI or something? Sorry. No, I remember. I did answer your question. I'm having a test to check ambiguity of grammar with parse trees tomorrow. Cool. I'm just winging it. To be honest. Like academics, you go too much into the details. No. Just make something work. No, it's fine. What? You're not using NeoVim? What are you using? VS Code? Emacs? I will never go to something else. That's for sure. I will, if something doesn't work in NeoVim, I will make it work and continue to use NeoVim. Or give up on it. Just live without it. Like for example, like debugging in Zig. I haven't gotten that to work yet. Like running a debugger, you know, with DAP. So debug logs is the way to go right now. Okay, but sometimes debug logging is more what you need as well. But yeah, anyway. Okay, so what leaks are we talking about here? Parser. Oh, the parsers. Okay. Well, I guess we could include it here. We could go through all the documents. Preferably before. And then we can deinitialize the parser. Because there's like two arenas, the parser and then the rest. There we go. Yay! Okay. Now let's see. Oops. If we can import a library. Okay. Helix. Oh, I see. I've never used that. What could you give me? I don't know, a sentence to explain why you would switch to it. OCaml is theory and production, albeit on yes. Vim, NeoVim is my favorite ones. Yeah, I've been using like Vim on and off. I used like Vim on and off for a long time, and then I switched to like VS Code for a while. But then I switched to NeoVim when I'm just gonna create my config. I'm just gonna spend some time to just create a config and just go with NeoVim, and then that's gonna be the way to go. Because I felt like Vim was too archaic, like the Vim script stuff, and like Lua is fine. Okay, so let's see this error, not dir. What? Well, okay, script execution error. So if we, for example, do print ASTs or print AST, you get the AST. So that works, but it's the script execution that is that doesn't work. So we run the statement. The problem is, where is that happening? Catch error, render evaluation error, script execution error, script path start line. Now this span is just the whole statement, so switch because I need a little less config lines. Found a Helix as most plugins I use a lot with Nevim built in. Oh, okay, cool. So then you can just install it in Nevim and you'll be fine. Do you have like Vim mode in Helix? I guess. Okay, so something in here is causing an issue. Let's do, it's gonna be, well, it's gonna be in here, I guess, as well. But it is like not dir, so I'm gonna assume I'm gonna log this here. Do we have like a logger here? No. Let's do a JSON format of import yeah, okay, importer is not absolute, so that is an issue. It needs to be absolute. Yeah, that is stored in the AST. Self path. I mean, I guess technically it could also be relative to the current working directory, to be honest. Did try running Nevim inside of Helix. Thank God it didn't let me. Okay. Like open a terminal and it's still model editing like in Nevim, but it has big difference. Every time you W, it highlights, selects the word even in normal mode. Okay. I mean, yeah, I don't know. It would be cool if, like, you in Neovim now, you have like tree sitters, so you can make like text objects using tree sitter queries, which is pretty cool. But I rarely use that. I mean, I think the only thing that I'm using is basically, let's say, but very, very seldom though. Let's say you have two arguments. like this, but then you want to swap the places. So I have a I have a thing for that. Swap the place. Except this is not really a text object, but it is using text objects, I think, for finding the things or something like that. Or you can like, yeah, actually what you can do is you can change out one parameter or delete a parameter like this, which is pretty cool. That I'm actually using quite a bit. Or change a parameter to something else. So that's actually quite useful. So that is using tree-sitter queries to do that. Yeah, current working directory is project root. I mean, the idea is that you would call. No, I guess the project root. Well, it's not really a project, so that is from the start is a false assumption. It's a scripting language, so you wouldn't create like a project. I mean, you can, I guess, if you want, but it's like the idea of the language is to just make these quick and dirty, scripts that do some useful things. So it's a bash script, so it wouldn't have like a project, configuration file or anything like that. You would just create a script file and run it. So the imports, I mean, yeah, it's just to make it like convenient. Like if you want to, let's say you want to import some standard library, if you have it installed somewhere, and you can like, okay, let's say, something like this, except that we don't really have, dynamic imports right now. But I don't know, something, something like that, maybe. I don't know. So that you can maybe use standard functions and stuff in this. Maybe we'll see what happens. And actually, we don't have environment variables like this either. Maybe this could be an environment variable. Not sure. Because then we can actually use then we could actually, when we run it, we could parse this. This would not become like a dynamic really. It's more dynamic every time you run it, but we would know the value at like parsing time, compile time. Anyway, because yeah, the thing is, like, if you say you run, let's say you want to run this file, but you run it from another, you run it from like source, and you run test. So now we should really treat the entry point as the current working directory. No, okay, that's bad. We should treat the entry point as the base of which it's importing things. Like if this is imports lib.rm, this should be relative to this script file. But the current working directory for executing commands and stuff, that should still be, the actual current working directory, like this directory here. But when evaluating like paths for importing, they are always like relative. It's like zig. They are always relative to the script that imports the other script. No, but let's say you have installed, like, personally you have installed like some kind of standard library in home runic standard.rm or something like that. Then you should be able to just import it like this. Presume, like, we don't have environment variables right now, but you should be able to do something like this in that case, to just access the standard library. I mean, technically, you could also potentially store like an maybe like an alias config in your Runic config somewhere, and that like a global config maybe, and or you could also have like a local config, I guess. And then if you import standard, maybe that could point to the correct place or something like that. Like if you have a like that could also be an option that we could do. But yeah. Anyway, let's see. Okay, so the problem is I want this path to be absolute, or at least that we should be able to make it absolute. It's supposed to be like relative to either current working directory or absolute. So that when we do an import expression, the importer needs to be absolute or relative to current working directory. This, however, is relative to the base dir of this. Yeah. So when we resolve the module path, which we are doing in, let's script executor. Where is that thing? Import. So here we're doing this, get cache document, resolve module path, importer module name. We're simply joining this, but the problem here is this is not a dir, of course. I think that's the issue here. So we need the base name of the importer. No, not the base, what I'm saying. The dir name. Dir. Why do we get null? If the path is in the current directory, the returns null. Okay, but couldn't we do this in that case? Or just dot. I don't know. Maybe this is better. So this would be like the importer dir name. Importer. And then the module name is always relative to the importer dir name. And that would be the path, except this I think this needs to be like absolute. Well, it's better anyway if it's absolute. So we'll join that. Or we just do current working directory real path alloc. Oh, but we need to join it. Okay. So this is relative, and then we return wait. There we go. All right. Now we're getting maybe somewhere. File not found. Interesting. From where? Real path. Okay, so let's catch this. If we get file not found, then I want to log file not found relative, and then yeah, still return the error. Otherwise, we'll return the error as well. Well, okay. We'll just return the error, yeah. So now we should see which one it is, maybe? No? Oh, this is in the document. Okay. Well, we'll do the same thing there. 77. And that would be path. Okay, file not found test. Oh. Okay, so let's do this, and then we do that. All right, we got a little bit further maybe. Document not parsed. Yeah. We have to make sure that the document's always like this, this path, and the map. The key here is always the like absolute. I mean, it has to be consistent anyway. But I'm picking just absolute because I do. Resolve path. So that should be absolute. Document not parsed. Okay, let's go to run script, parse imports. So let's do some logging here. Let's say parsing import path. No? It doesn't actually do it. Interesting. What the hell? Did I forget to save? No? So we don't actually get in here. Strange. Okay. Let's do print ast. So we do have an import statement here. Let's go to Import expression should be here, I think. Yeah. So here's where we like write out the thing. So let's do like from importer module some indentation. Okay, from test module. Yeah, so we have it. So why are we not parsing it? Script AST. Yeah, that comes from there. I'll say like, how many statements do we have? And then here is like statement, parsing statement. Oops. Statement. Oh yeah, it's just the tag name. Parse imports one statement, a binding declaration. Oh, okay. Oh, shoot. Okay, we have to actually traverse the whole tree to find all the import. Stuff. Right. I was immediately thinking about writing an iterator for this. Like statement expression iterator that would like filter on, or just expression iterator, like you're just walking the entire tree getting all expressions in order. No, this would be the script. Syntax. Okay, how would we do it though? We need some kind of selector cursor into the script. How would that look? I mean, we can have like statement index. If this is more than or equal, we return null. But then we get like the current statement. How would we then... Okay, I guess... Yeah, because each statement could have a number of expressions depending on the statement. So if we switch on the statement, we can have a bunch of different choices. And I guess I'll go through them one by one here. Let's do that. Alright, binding is 1, so that would be something. Function. I don't think we actually need... Actually, you know what? Functions could have bodies with imports, actually. Unless we only support imports in the root. But that doesn't... No. And then you would probably wouldn't want to execute the import in the function until you call the function. We could parse it. We probably could parse it, but not execute it until we reach the point. Yeah, but that's gonna be done anyway. We could parse it, but not execute it. Yeah. So we could actually go ahead and look at the function actually. And then we have an error declaration. I don't think this is gonna have anything in it. Return statement. Well, that could have a... For importing every time in a loop. The bash block is also interesting. And then we just have expression. Okay. Yeah. So let's say, for example, the bash block, it shouldn't have any expressions in here that we actually import stuff. So that one, I think we just return next again. So we skip that. Return could have technically a thing, an expression in it, so... And technically an expression could have multiple expressions in it. So I'm wondering how we would do this, like, because it's like each of these needs its own thing. I think the expression could, maybe we could like make a recursive iterator, like each expression makes its own iterator, maybe. We'd have to like deallocate this. We could have like a list of like expression. So this would be more like statement expression iterator. And then we have another iterator, which is the expression iterator, which goes through an actual like expression and iterates over all expressions in the expression. So expression is Runic AST expression. Could also be a pointer, I guess. And I'm not sure how this would work. This would probably also be very switchy. But basically, once we have this, we could just use it everywhere here and have like current expression iterator or something like that, and it would, yeah, unless we have somewhere where we could have multiple. There's also things like for statements, while statements could have several statements in it as well. The function body also has statements. Okay. So we could have like inner statement, but that would be a recursive thing. Though you can have loops in loops and so on. Function declarations, I guess, could be anywhere as well. So we would probably need some kind of list of things, or make it like a recursive structure, probably. But let's do this first. Expression. So I mean, okay, let's just switch on the expression and then see what we can do. We have all of these things. Holy shit. Okay, so maybe we can have like an expression stack that we like, when we run out of expressions in this expression, we pop the stack and we go back. That could be something. No. Okay, so I'm just gonna do like this and that, and then the identifier. Well, actually, let's also do this. Whoops. No. Why am I pressing escape? There we go. Okay. So we get identifier. And this one. Yeah, that's just the identifier. I mean, that we should just return this straight up. And this would just be like return the expression itself, and then we're done. So we'll have the original expression, I think. We'll have like expression stack. We'll make this managed. Or we could have an allocator in here. let's make an init function. Now this will probably be part of the script AST instead, but I'll put it here for now. Okay. So now, for example, when we reach the expression, we would always have a expression iterator, which how would this work? Well, I guess we could reuse the same one. Or we could have just have the stack in here, I guess, also. Yeah, let's just have the stack here. Expression stack. Actually, yeah, because when we get here, how would you know where you are? Like, this could be part of the cursor structure. Either we're at the start, we have a statement, so I guess we could make a cursor struct. Do you have precedence climbing algorithm or to parse expressions? I don't know. Yeah, I have a tokenizer. I just turn everything to tokens. Then I look at the first token and go from there. It could be any potential, like, or any valid token that is like the first token, and then depending on which token it is, you can have further narrow it down to other parsers. So maybe, I don't know. We'll do this. We'll put the stack let's have like cursor here instead. Because then we don't actually need to store this. We can store the cursor there, but we just use this as a function there. So it's not really an iterator, it's more like a helper thing. So I think it's like if the stack is empty, we will look at the statement. Well, this is cursor. If this is empty, we will now if it's not empty, we will return next maybe like this. But once it's empty, or actually if this you know what, let's do this a little bit more let's do this, maybe we'll take a, maybe this is a function that takes a type of expression that we want. Recursive descent. Yeah, that sounds correct. No, let's just do this. This is more general here. Let's do this first, and we'll see if we can. I'm basically thinking like, what? Okay, what about this returns null? Should we then go ahead and do this? Because this shouldn't return null as long as we have items in here, I don't think. Well, we'll figure it out. And that will like forward this stack. Next time this might be empty, so then we go ahead and read the statement. And we increase that for next time. Well, we can go ahead and do it straight away actually, but and then we read the statement and we build this, we start the stack depending on that. There could, however, be several statements in one of these. So you could have like also one expression could include another statement iterator. So man, this is a lot. Maybe it's bad to actually, yeah, okay, maybe this is why usually when I see ASTs, you just have a node, and the node could either be maybe a statement or an expression or something else. Because then it's very easy to just go through all the nodes instead of like having statements and expressions like this. You can use different precedence functions for different. It's more easy to use precedence climbing for parsing expressions because you have a function that parses any expressions and precedence function that tells what precedence each operator has. Okay. Yeah, I would have to check that out sometime. That sounds cool. You can use different precedence functions for different expressions. Right. That reminds me of, like, it's kind of cool in Haskell. You can actually set the priority of functions in the source code. Like if you have, because you can define your own binary, you know, symbol functions, and or unary. You can have unary and binary, and then you can also define their priority in different ways. in the source code. So it's like you have to, when you parse that, you have to like take that into account. That's kind of interesting. I just thought about like that's depending on the source code to determine the priority as well. Or the precedence. Precedence. Man, this is yeah, I think it's more complicated than it has to be. If I just say that everything is a node. But let's just keep going and see where we land with this. Because I don't want to like redo everything there right now. But that's something to think about for future projects probably. That it would be easier to make like walkers like this with that structure. But you still need to treat everything differently though. Okay, just as we have expression stack, maybe we also need statements as well. You know what? I'm gonna just forget about functions, forget about for statements, while statements. I'm just gonna say, yeah, if you have imports in these, this won't work. I'm just gonna say like that. For everything else, we'll see if we can get there, but for everything else, I think I'm just gonna try and make this work here. So here, for example, we have the cursor. Now, if we get the current expression, so we pop it, I guess, from here. Now it has to exist because that's just how I built this thing. So we pop it there. We should now have the expression. And then we switch on it. If it's an identifier, we just return it. So we don't produce more expressions. I'm not sure how this is gonna work, but we'll see. Path? What the hell? Oh, I think maybe this was for like imports. We don't really have this. Whatever, that's fine. Also, the segments are identifiers. What? Wait, path represent quantified identifiers such as error, not fun. Oh, okay, that's different. But anyway, we don't have like expressions in there anyway, so that's fine. Literals should not have multiple things except for strings. The strings are the only ones that has expressions in it. But you wouldn't be able to have an import there anyway. So I'm going to ignore that. Arrays. Technically, I guess we could have like imports in arrays. So if we encounter an array, we have elements. This is like a comp time known array. So we can actually push all these elements onto the stack now. But what would we return though? I guess we would return self next. But if the elements are 0, what happens then? Huh. I guess we just return the array expression itself. So maybe we don't pop. Well, we can push it to the stack again, I guess. Well, but then we have an infinite loop. Maybe we don't pop then. We only pop if in these cases here. So we'll do like get last. And this should pop. I'll just put these on the same line. Okay, so this should be like append slice, and of course this we could just say this would be a constant pointers. We don't need to modify it. So that's fine. We append this. Well, I guess it doesn't really matter. We append. Well, oh, I see. The pointer is not constant. The array is constant. Okay, so that doesn't matter. So we will try this. Actually, yeah, this would be like an error, and then we do try here. Except we don't need to because we're returning, but whatever. Okay, so we append the slice, and then we return self, or we return next self. So what's going to happen is we encounter an array, we add all these elements to the expression stack. So now we have the array first and then all the elements on it. But okay, I can see why this won't work actually, because when we, okay, then we pop off every element, but when we reach the array, we go through this again. So we have to pop. But when do we return array? I guess we just append the slice and then return the array. Yeah. And then the next time we just go through all the elements. Yeah, okay. Okay, then we have maps. Map. I don't even remember having this. I think I'm just gonna ignore this for now. We're just gonna do like maps not supported. Actually, you could do this. You could do like inline. Or it doesn't need to be inline actually, but or I guess it does need to be inline. No, it doesn't need to be inline. We can just use, we don't need this. We can use tag name of the expression itself. All right, range. I'm just gonna put, actually range. Okay, it actually has start expression, end expression. But that doesn't make sense in when importing, so I'll just do this. Pipeline. No, okay. Actually, you know, we do have expressions here, so we should we should walk through them. But okay. So I'm just gonna do like append. Start. And if there is an end, we will append that as well. Oh, hang on. Let's make this managed. Okay. So we append that, we append that. So we're basically just finding all the expressions within the expressions, and then we return the expression. Okay, okay. Pipeline. Same thing here. Although you wouldn't have an import in a pipeline, but this is a general expression walker, so we'll go through pipeline stages, and then stage has a payload that could be an expression. Commands is also, it's not really an expression, but this could be an expression. So this would be like try self express stack append this. All right, and then we return this expression. Actually, we could just return the expression at the end. We don't need to do it every. Let's also just add map here. There we go. Yeah, that just adds all those pipelines. Call. Has a callee, which is an expression apparently. Yeah, I guess it could be an expression. I guess you could have an import and or I mean you could have like a scope accessor or something. So we'll do that. Actually, then we can do this for most of these. Okay, member object. Index, target index. Maybe we could implement these on the actual ASTs themselves. Or technically, if everything, okay, this is where comp time actually could be good to use, because you could automate this actually. You know, if you could, every expression is a struct. You can loop through all the fields and find all expressions and add, like, use that information to add, like, find which field it is, and then you can add it automatically. Like, that is possible. However, if you add something that is out of the box, then you would still need to yeah, do some changes there. Is the operand? Okay. Block has statements. Okay, this is where it gets a little bit hairy. I think I'm just gonna say that we don't support this, because I'm not sure what to do here. I think we would need to now, unless we can like wrap them in expressions or something. Or this stack, actually, this stack could, oh yeah. We could do this. We could do like stack item is a union enum of either a statement. Aha! Or an expression. And then this would be just a stack of stack items, and we wouldn't need the statement index now, because we can use this stack here. So we can actually, okay, we don't actually need the expression iterator either. Well, okay, let's do like function next expression, and this would be like self I don't think this could be mobile. We'll see. And then basically we're doing this. Okay, so we're looking at the expression. That is if we already, like, if we have an expression, I think. So basically we need to get the expression here. That is the next expression on the stack, so it should have been popped then. Yeah. But this would be more like, not really next expression, but populate expressions or something. We could have that populate expressions. Populate stack. With expression. And then we don't really need to return this expression, because that's always going to be the case. But it's going to be like a void. Okay. I'm gonna get the cursor and we'll replace this by cursor stack. Right. So when we initialize with this, we start the cursor actually with some statements. And an allocator. We'll just copy that later. I think that's fine. You can just copy it later. I'm pretty sure. Then here we would append slice. But I guess could you do like init buffer? From own slice maybe. But that's not entirely correct though. No, we'll just do init capacity. Statements length. It's gonna be more than that though, but whatever. It doesn't matter that much. But now we can like assume capacity, I guess. No, we don't. We will have to loop through all the statements. And we would do list append assume capacity. So this would be statement like that. Okay, so now we can initialize it here with allocator and script statements. Oh, and those are pointers. I saw. There we go. Which is good because this is pointers as well. Okay, so now the cursor is, we can support both expressions and statements. So whenever we encounter more statements to add, we just add them. We encounter expressions, we just add expressions. Now, here, we probably, it doesn't really matter which order you're doing it actually, but I think the correct, if we want to pop, is that we want to add them in reverse order. So let's do this. We'll add them in reverse order. We can also have convenience functions, I guess, like append statements. No. And that will basically do the same thing here, except this is that. Now let's do cursor. I'm pretty sure this is safe. There's no like arrays or anything. Yeah. Okay. All right. Append statements. Let's do append expressions. And this would be expression. Actually, this has to be length, yeah. And we don't assume capacity. Well, we could ensure capacity, I guess, before, but this is more like, well, okay, fine. We'll do statements, ensure, no, self stack, ensure capacity, ensure unused length. Same thing here. There we go. So it's being added in reverse order, so that when we pop it, we pop the first one that we just added. Okay. Yeah. So now we can say instead here we can do like append expressions. And well, I guess it's good to have singular form as well. Okay. Wait, are you? No, you are expert. There we go. Okay. So you will be like append expression. Yeah. So basically everything. Like stack. And then append slice would be append expressions. Wait, but this is not append slice. Oh, it was wrong, I guess. Append expressions. Right, so then when we have the block, now we have statements. So now we just append the statements. So we just do like append statements, block statements. Nice. So now we have support for the cursor to have both statements and expressions at the same time. And then when we do this part, we will pop the next item. And if it's null, we return null. But if we have an item, we will kind of process it depending on what it is. So if it's an expression, we will get that, and then we will call populate stack expression. If it's a statement, we get the statement, and we will populate, you know, we will do the statement equivalent, possibly. And then at the end, we just return the item. So that is the, I think this is the algorithm that we found here. And then I will just remove all this, and U will be put into populate stack statement. And we just populate depending on what is happening. So you wouldn't have anything yeah, expression actually has expressions in it. It just has an expression. So we would just do like self cursor append expression dot expression, and then we're done. We're done there. Binding has stuff. What do you have? Things. Initializer. The binding pattern could either be, there could be things, but no expressions in here. So this is the only expression, the initializer. So we will just do cursor append expression initializer function declaration. Yeah, so now the function has, well, the function has the body, which should have statements in it, or it's one expression. Oh, actually that's super easy then. We just do like append expression function declaration dot body dot expression. Wait, what about this? What is this? A block? Oh, I see. Well, what is expression then? Maybe it's like the final thing? I don't know. The result? I don't know actually, because most of this was made by AI, so I'm just picking up the pieces from where the AI left off. Okay, so let's see. Yeah, we need this expression, but we also need the statement. So I'm gonna assume that the statements should be first. which means we put this on first and then we put the other statements, which is in the block. Now, what you could do is perhaps make an interface, kind of. It's not really an interface, but you could make an interface in any of these things. Well, it's kind of what we're doing here. We're implementing the same algorithm for different kind of things, but you could make a function that takes anything and then, or takes an expression or a statement, and it's kind of what we're doing here. But you can also put it directly on here that has like a function which should be named something common. So every expression here should have the same function name, because then you can just call that function directly from here and it will pick the correct one, because of the compiler can know which type it is there. So, but anyway, we'll do it this way now. Error declaration. What do you have? You have a body. What? Oh, but there's no expressions in here. No. So you actually don't do anything. So we'll put you over here. I'll put you over there. All right. Let's do the loops. So we have 4. You should have a body with stuff. There we go. Sources. I guess we'll do like body first. Body actually has like an expression as well, I guess. No, it doesn't. Wait, how does this work? Oh, it's a function body. It's different. This is just a block. I see, I see. Yeah, for statement capture can have bindings. Yeah, those doesn't have expressions. And then we have sources, so we'll just add those here. This should be append expressions. List of expression function or pointers. Was there anything else? No. Okay. Should be kind of the same for a while, I'm gonna guess. Yeah, we have a body. Wait. Statements. And then, what do you have? Whoops. Same thing basically, except it's just one condition. So it will be an expression there. Okay, return has just one expression. Whoops. So we will cursor append expression. There we go. All right, that's all the statements done. So that should all work out like recursively and stuff. We just need to do the rest of these. Okay, function literal. The hell? I guess we do this. So let's do like the body first, expression first, and then statements. And then there was there anything else? Return, no. Function literal, like is this a declaration of a function except it's like an expression instead? Because it's not a call. Default value, oh. Okay, I guess we have to go through like the params. And if we have a default value, we will add that here. Okay, so we have the body expression, we have the statements, and then we also have the parameters, default values. Yeah. Yeah, there's a lot of these. This should just have one. Oh, it has a body. Okay. Yeah, so this should just be like pen statements or cursor body statements. There we go. Await. I'm not sure if how those are gonna work. By the way, this is just, you know, remnants of the old way. I guess this is the same, maybe. No, it's just one expression. But we can have a catch clause and a capture block, I guess. I'm just gonna... We'll probably change this. Let's just do everything, I guess. Okay, await catch clause. Oh, this is a... Okay. Statement, so... Failure, so it might not exist. So we will do like if await failure we get it. Was there anything else? Subject success. Also has a capture. Wait. This is a capture block. A capture block can have a capture clause. Okay. That's it. I thought it was like recursive or something. Okay, cool. All right. Where are we? If, as I said, with this we could have walked through with like zig comp time, walk through every field on every of these structs and try to find expressions or statements like in using comp time, so you wouldn't have to manually map all this. But also, as I said, like that could also lead to problems where if you go like slightly outside the box in a case where we haven't we don't have support for yet, then you would need to handle that. And I guess there are ways to kind of fix that as well. You could have like an exhaustive switch that would fail and that you would have to like implement. Make sure that you have actually implemented new patterns. Okay, so here we have like condition, we have capture clause, but that just has a binding, I think, and then we have else on the block. So so condition happens first, so that should be last. Let's just do append expression, cursor. Condition, and then it should be the else, and you have what? A block or and an if again. Oh. No, you're either block or an if. Okay, so this is recursive now. So then we have to make a function here. We have to make like populate if expression. Let's just put the cursor here. And then expression, so if expression it doesn't really need to be a pointer, but whatever. So instead of doing this, I will put this here and I will call populate if expression with the cursor and if expression there. All right, because now we can call this like recursively instead. So if we have an else branch, we need to switch on it, and if it's an if, we get else if expression, and we call populate if again with the else if expression. Or it could be a block. I mean, blocks are so usual now, so let's just add a populate block. I mean, it's basically just an expression or statements. Okay, that's the else. Now we have the then. Wait, no, else happens first, there we go, or last, so that should be there. And we have then block. This is a block, so we can just call populate block right. There we go. I think that's it for all of these if stuff. Capture doesn't do anything. Span doesn't do anything. Condition. Yeah, there's only 3 things. There we go. Okay, we can switch these out for populate block expression. Same here. It's not that huge of an improvement, but whatever. Same thing here. Probably a better pattern to have like 1 function per thing anyway. And whenever, if we change the block, you know, to have something else, then it's gonna be a more centralized functional like place where you actually, where we could haram block. I mean, okay, technically I could just call this again with the block, but whatever. I think this is better because then you'd have to switch on it again. Okay. If, so that was the if. That was a lot of stuff. Match. What do you have? Subject, match case. Okay, so subject there. So that should be first. And then I think it's like expressions, maybe. No, wait, we have to loop through the cases. And what do you have? Home. Pattern is not gonna be any expressions. Capture clause doesn't have expressions. It's just a block, okay. Okay, so it's just populate block or body. There we go. Except now it happens in like not reverse order, but okay, whatever. It's not really a huge deal. Try expression just has 1 expression in it. Catch. Yeah, what do you have? God damn it. Subject, catch clause. Okay, wait, no, catch clause can actually have, wait, a body. Capture clause. Okay, so capture clause does not have a body. Catch clause does have a body. Right. Subject, handler. Okay. So and expression. No. And it should happen there. Import expression. The old familiar import. That's just nothing. Okay. Wow. Okay, so we made, what have we made here? We've made a expression, like an AST node walker, you could say. Like it walks through all of the expressions in the tree, in the AST tree. And yeah. And we're using like an array list instead of a recursive descent, kind of. We're using an array list to keep track of all of the expressions and statements that we need to handle. That is like currently in the queue. And then we just pop the one that we have, and we analyze it to see if we need to push more things on the stack from this from this expression or statement. And if we do that, then we have more things that we need to pop later. But for this one, we just return the item. So next time we go in, we have more things that we pop and so on until we've reached the end of the things, and then we just return a null. So cool. I was really unsure on how to actually make this iterator, but I'm glad I did, because I've never made this pattern before. It was very interesting. So we'll make a deinitialize. We'll deinitialize the cursor. It's just gonna be like the stack. I think that's it. Everything else is not really managed here. Okay, cool. So when we initialize this, we put a script in there. That's gonna do all that. I'll just make this a pointer just in case. All right. Now, where do we... Okay, so we have this. So the whole problem here is, like, when we're trying to parse all the imports, we only looked at the statements that was immediately in the first script file. But those statements could have import expressions that were, you know, not immediately in like some kind of expression here. So I did this walker so I could make sure to visit every expression in the tree and check if it's an import expression, and then we can actually parse it and import it. So let's get rid of these logs here, because they will tell us if we actually parsed it. So that's how I noticed how we didn't parse the import. If you look at this file here, this import was not parsed because, well, it would have been parsed if it looked like this, because this is a different, like, this is just an expression and it's just a import expression. But this is a different expression. This is a binding expression or statement, which includes an expression that imports, but we didn't check these kinds of expressions. So now we make sure to look at every possible expression to do that. So we can keep these logs here to see that we actually succeed. So instead of doing this, and I don't really care about the length of the statements anymore here, I'm gonna make an iterator, and that's gonna be like a statement expression iterator initialize allocator and the script. All right. And now we have our iterator. I guess we have to try as well. So we have our iterator. Now we can do, instead of for, we'll do while iterator next. Actually, we have to try. And we will get out a node, sort of. Well, it's actually, yeah, it is an expression. So we get an expression. And it's probably better if we get like, maybe it's better if we get like the statement, because statements could be good to have as well. But I don't know. Anyway, C program lover, hello, hello, hello. How's it going? Also, thank you for the follow, C program lover and that guy Doru. What are you doing now? I'm working on making the imports work. So right now, I'm parsing. I'm trying to make sure that we parse all the imports. So it's like when the scripting language parses this file, it encounters all the import expression that it encounters. It should also load this file and parse it as well. Also, I don't have detection for circular dependency, I just realized. So you could, if you import the same file, well, if there's a circular dependency, there's probably gonna be some issues. But I don't have that. But you could have if you want. And then it will probably crash in some way. But anyway, before, the parser would just go through every statement and look for import expressions like these, but it wouldn't find import expressions like these that were hidden in other kind of expressions here. So that's what I did. I did a kind of expression walker that would walk through all different expressions in the whole AST tree and look for import expressions. So now that we have that, we can, I'm making this iterator a new instance here, and then I will loop, like go through all the iterations here, and we'll get the expression out. And I was contemplating if I wanted to make it so that you could have like statements also, but nah. And I will look at this expression, parsing. Yeah, I'll just do this so we can see that it actually walks through. What editor are you using? I'm using NeoVim. Let's see, so this switch we don't do. Okay. Okay, whatever. Let's just not make it a pointer, I guess. All right. What's this? Expected type. Found block. Oh, but here we can use populate block instead. There we go. Well, they don't really need to be, you know, they don't need to be mutable. We could do constant pointers, I guess. But no, let's do this so that we can keep the pointeriness all the way through. So we don't actually copy something by accident. What is this? Return statement value. Oh. So we just need an if here. Good morning from Boston. Good morning. I need to fix something to eat soon. Duplicate switch value. What? Oh. Alright. Expected this, found that. Alright, let's do this then. You need cursor. And probably this, maybe. Alright, it wasn't as straightforward as I first thought. What's this? Oh. Alright. Wait. Why is this const now? Huh? Is it... Wait. Is it because of this? No? The Wait. Well, I am tempted to just get rid of this whole pointer business. Why would this be const now? Like, this is it because of this is like const match case? Probably. Why is that not showing here? I guess the LSP doesn't have support for that. Okay, you know what? Let's just get rid of all this pointer stuff then for the blocks. And then we don't need this, I don't think. Wait, error union? Oh, wait, what? Okay, one of these is missing a try somewhere. There. And fine. What is this? Stack item. Oh. Right. Okay, so actually, if we have a statement, if item is a statement, we okay, while the item is a statement, item is equal to next self next. No. Cursor stack pop. No, this doesn't work. You know what? Let's just return a stack item instead. And now this is like a node, and then it's like if node is equal to a statement, we continue, but then we get the expression from node expression. All right, there we go. No more compilers. Okay, now we get the import expression here. We're importing this file. Okay, and then there's something going wrong in the script runner here. All right. One second here, I'm just gonna order some food, and when that arrives I will probably call it for the day. What? One second. Drinks. All right. Once we get this done, the imports will be done. I think you can import things. It will execute the stuff in the import. You will have access to the scope in the imports. And yeah, it's got to be a good time. Okay, there we go. All right. Okay, so we'll remove this now because we know it works. Cool. All right. So the error says that it's trying to access expression while command is active in run script 201. What? Oh. Oh, I see. It depends on the payload. Okay. Yeah. Okay, so the payload can either be an expression or a command. So if it's an expression, right. So we'll just do like a switch on payload. And we'll get the well, can't shadow, so payload expression. Right? Unknown. You can't do this? I'm pretty sure you can have an expression after 4 without, that's not a block. Okay, whatever, let's do this. Maybe there's something else wrong here. Oh, I see. Yeah, it's expression. There we go. And if we don't have that, then we don't do anything. There we go. Again, this should happen like in reverse order, but whatever. Okay, we got some other issues. Right, so now we get here, like evaluate the import expression. This tells us that the executor is trying to execute this. So we're past the AST part. So if we run print AST, we will get this, but we won't see the AST for lib. I mean, I could add so we can actually see that. There, print AST. Except we haven't parsed the imports yet. We should do that here. And now we leak memory. Why? Oh, we need to deinitialize the iterator. No, still leaking memory, okay. Run script, resolve module path, 286, 268. Oh, this path, but we're freeing it. Or is something in here not relative? We need to free relative. There we go. There we go. Do you know Python? A little bit. I haven't made like any large projects or anything, but I've been, you know, I've seen it a lot, and I've tried it a little bit. I did make like a very simple game in it once. Like a game with no graphics or anything, or like very simple. But it's fun. It's very productive language, I would say. Like you can get going fast, and the syntax is simple, and I mean I like, you know, I like space indentation based blocks. I can deal with both. I don't really have a preference, but I like both. I know that some people can have a hard time with space indentation, space-based indentation, or wait, indentation-based blocks or scopes. There's a problem with VS Code. Can't give input values, showing you can't edit in read-only memory editor. Okay. Well, if you can't edit in read-only editor, it sounds like some kind of permission issue, or you're viewing something that can't be edited, I guess. It's hard to tell without more context. Like, is it a file on your local drive? Yeah, ask ChatGPT, yeah. That could actually be a good idea, you know, sometimes. We'll replace duck programming with GPT, I don't know, GPT assistance. Okay, wait, where were we? Yeah, so we're parsing it, so now it should be good to, when we print this, where do we do that? We're printing it here. We should have like a bunch of documents to print. So we could go to the document store and the map, and we could just loop through all these documents and do this. There we go. Now we have like AC for all the documents that we are ever importing. So here's the main file, entry point, and we're importing lib. And this one, now we're showing all of this. So we have a declaration there, name binds to a pipeline, where we echo lib. Then we have an expression statement. Oh yeah, we're echoing that. Okay, cool. So we have all that, but the problem now arises when we try to run this. Attempt to use a null value. Okay. Interesting. Evaluator 243. Okay, so apparently this is null. Okay, we'll have to go through all the cases where we try to use this or set this. So here, for example, here we're not setting it at all. When we import something, like here, we actually do set it here. Here we are setting it here. However, the current one, so it could be the first one, the entry point, we're not actually setting. Although I do remember that we did something like that. No, here's the executor. Maybe we didn't, maybe we missed it. Do we have the entry document somewhere? Yes. So we could say actually entry document dot script executor is equal to that. And then I will Do this. Wait. What? Now, yeah, like that. There we go. There we go. Wait, is it only leaks? There's a lot of leaks in that case. Yeah! Alright. Let's get rid of this debug log. Where is this? Here. Alright, we got a bunch of leaks. I'm gonna look at that in a second here. But it does work. Hey! Okay, let's look at the leaks here. So command runner has leaks. Okay. I think if we go to document store, deinitialize document. We are deinitializing the parser. We're not deinitializing the script executor. So let's see if this fixes it. Nope. Well, it fixed most of it. Oh, now we get execution error. Okay, well maybe we did that anyway. Oh, and we get general protection exception as well. Oh, 1 second. I just have to go pick up my food here, BRB. All right. Let's see. Let's just finish up here a little bit so we can leave this in a good set. I'm gonna push this up, and I will also make it like the repo public as well, because I don't remember who it was, but it was someone who wanted to make a game using the language. I don't think that's gonna be very easy, but that would be very cool. But okay, so we got a couple of errors actually here, which is weird. But this would be okay. So unknown identifier lib. I mean, that's from here. Unknown identifier 6.1. That's also a weird place for the error to be. It could be that this is parsed as like an identifier, not a pipeline. Maybe. If we print this is just an identifier. So it's not really parsed as a pipeline. But what if I added... How would this work, actually? Okay, we don't get the error anymore. Anyway, I will remove that. Yeah. So now we get a general protection exception. Again. Alright, so let's see. Scope 28. So we got something wrong with these bindings here. Alright, so last time we got this, it was because of the allocators. Like I had an arena allocator, and then I made another arena using the same arena allocator. So basically like a nested arena. And that seemed to have caused some issues. I'm not sure if that's was the actual issue. I never like looked into it that much, but I just solved it by separating the arenas a little bit. Here we use some kind of allocator, and we're calling deinitialize. It's just the initialize here. So it's during like the deinitialization. It could be that the allocate, like we used to set another allocator. Whoops. Because if you look here, this is like we're evaluating the import expression. So here we actually we're creating this whole new script executor here, and we're using self allocator. And push frame. And then you should, when we run execute, you're creating, no, we have an evaluator. Where is that made? Oh, it's made here with the same allocator. So we don't have like a arena or anything in here. Oh, wait. Where was this? Scope. What the hell is this? Frame copy, pop frame. Scopes the initialize. No, it's the initialize of everything. Documents stored initialize. Okay. So what if we do it in another, we do parser after. No. That would be too easy. Or I mean, yeah, after, that's right. The bindings. Evaluator. I need to understand this because how, like, let's say we have an identifier in the scope that's set to some kind of value. That's stored in the scope. Here, the scope stack. And we have frames. And those have bindings. The bindings have a value, a name, and so on. The value can be any of these. Maybe it's something to do with the scope. Also, I'm gonna remove this type expression here because we're not using it and we probably don't want it. Okay, so should I just do you have clone? No. This is annoying. Where is this call from? Why do we have these? Binding scopes, lookup name. Like, because these scopes, is it just because you want a cloned value that you want to use later, maybe? But and what are you then? So we might we might then end up with like duplicates. And but then you would just get like double free. Like there's an error in Zig where you can get like double free. Oh, we're deinitializing it here. And then trying to access it again. Oh. I see. And that doesn't actually do anything though with the scope stack. Yeah, I don't understand. Run script 49. Yeah, that just initializes document store, which in turn initializes the script executor. What? Wait. Aha, we don't we don't deinitialize this executor because we already do it in the document store. There we go. Oops. No. Wait, now we have a leak instead. Okay, well that's better. Evaluator 254 context. Ah, I see. Okay, so right, because this is a pointer here, yeah. All right, so we'll do the same for the context. We'll deinitialize that. I will. Well, where is the context? Oh, it's just there. Huh. So we could probably just kill this off here then. Like deinitialize it at the end of this, maybe. Hey, Nav Gaming, what's up? There we go. Okay. Cool. All right, so let's look at this. We have. I'll just get rid of this all crap over here. So basically, we have this is. Oh. Okay, now the LSP is acting up here. Okay, well, we would have to. I just want to look at this. Segfault. Okay, I'll fix up the LSP later. Let's do like yeah, this is done now. This is so basically okay. So if you look at this, here's test.rn. And if we open up a terminal here, we can run this. And what will it produce? Well, it imports lib here. So we have lib.rn here. This will create a name that is this is process here, echo lib. And then we echo hello from, and then this, and that will convert like the standard out from this into this string here. So if you run this, we should see hello from lib, which we've already seen the way you get this. Let's see, and then yeah, and then you can like hopefully like later we will be able to like use lib in order to access name, for example, or other if I define functions from here, you could like access them from there. Okay, cool. So that is that. Okay. And if we go to the to-do, so we have moved the script executor. Yes, we do this. We create one executor for each import to be executed. The end maps we have to look at. I do believe we do pass it around. We're treating it basically like a global now. Probably change when we get to subshells. Quotation marks. All right. Then we have cache execution results. yeah, that is also, we do have that, but we don't do anything with the scope stacks yet. We store them, but we cannot actually access them. So that's the last part here. We need to wire them up in order to be able to access the declarations on the module itself. Yeah. All right. You decide you want to start learning 3JS, maybe make an app combining it with React. Oh, sounds cool. Yeah, because you can create like a web app using Canvas. Or a game. Okay, and then I'm going to also add this bug here. LSP now crashes. I'm not sure when what the reason was, but investigate that we do similar setup as run script. All right. So, but yeah, that's gonna be it for this time. I will push this up and make the repo public. And you want to make a game where you build PCs? That sounds cool. I think there's already games like that. You can look at, well, if you don't want to get influenced, don't look at it. But I think I saw some game like that. But anyway, that's gonna be it for this time. I need to go eat some food, and yeah, maybe I'll get better, or I mean, maybe I'll get back. We'll see what happens. But yeah, thank you very much for watching, and yeah, I'll see you later.